Alright, this is the final problem of section 13.3. This is problem number 68. Average cost. For the cost function, c equals q squared plus 2q plus 1, show that the graph of the average cost function is always concave up for q is greater than 0. Alright, so we need to turn this into an average cost function. So the average cost function is the cost function divided by q. So we have c equals q plus 2 plus 1 over q. That's our average cost function. So we're supposed to show that the average cost function is always concave up for a positive value of q. So let's find the second derivative of this function. So we have c, the first derivative is going to be 1 plus negative 1 times q to the negative 2 power. And then the second derivative is going to be two times q to the negative 3 power. So we have 2 over q cubed. So we're supposed to show that the function is concave up anytime q is positive. So we see that the second derivative is not defined for q equals 0. So let's look at that interval between 0 and infinity. Sorry about that. So let's look at the behavior of the graph of the second derivative in this interval. So let's plug in 2 over 1. That's going to give us a positive double second derivative for average cost, which means that the function is positive. This function's second derivative is positive from 0 to infinity, which means that the function is concave up from 0 to infinity. So essentially we have just verified that the average cost function is concave up for any quantity bigger than 0. And that's it. That's all we need to do for this problem. We're done.